Xavier Mertens he's from Belgium. He's been a science instructor for for a lot of years.
Not as long as you, but
Not, but many years already. He teaches, he's specialized in malware analysis, and basically he's a reference in the community. I don't know if many of you are familiar with this Internet Storm Center. It's basically an organization started by the Science Institute around year 2000. So that's basically 25 years ago. Xavier is basically one of the engines and one of the brains behind the ISC. And he's also he's a consultant, he's a free soul, doing consulting all over the place, blue team most of the time. And I was wondering, he's doing all this consulting, teaching for science, doing his research for talks, running the Internet Storm Center. Is like, your brain is going to explode one of these days. So tell us a little bit, how do you manage, first of all, if you want to share a little bit the Internet Storm Center, and then how you manage to have your brain not explode?
Well, the Internet Storm Center, honestly, it's difficult to explain in a couple of minutes. What I recommend you is just to visit the website, ic.science.edu, and to subscribe to the podcast. So Johannes did a great job every morning, because especially for us in EU, when you commute in the morning, when you take your breakfast, your first coffee, the podcast is ready. And in 5 minutes every day, you get an overview about what happened in the previous 24 hours. So it's super nice, super nice. So I encourage you to have a look at this podcast if you don't know already. Yes. And my brain does not explode. So basically, usually on Sunday mornings, at that time, I'm mountain biking somewhere in the woods, in the fields, and so on. So not this week, but that's for me the way to really calm down and be fully disconnected, because every Sunday morning, that's the only time when I'm not watching my notification on my phone and so on. That's my way to really disconnect, and yeah. But not today.
I'm sorry, my friend, but I'm sure
but it's for a super good reason, so there is no issue.
Thank you very much.
Okay, so thank you everybody for being here for my presentation. I hope it will be interesting. It's something that is not brand new, but let's have a look at how we can hunt for some payloads in the Linux extended file attributes. So first, let's see if it works. Yes, perfect. I think I will skip this because I already had a quick introduction with Jess. Most important, maybe, I like to hunt for malware. I like to hunt for bad guys. I always try to find new samples. I analyze them. And if I find something interesting, I produce some content for the Internet Storm Center. For example, what I really like is everything related to obfuscation techniques. It's crazy how people can try to obfuscate stuff. And sometimes I say, oh my God, this guy is super crazy. Nice ideas. But yeah, that's all about me. First, a disclaimer. We are good guys. So we are in the DFIR track today. And if I say that my title was hunting for payloads, I will also show you something, a proof of concept that I wrote to do nasty stuff, but we are defenders. So it's just a proof of concept, it's just a test, but please do not try to reuse this technique to abuse your friends, partners, colleagues, whatever you want, and so on. A quick poll. First, raise your hand. Who is aware of the Linux extended file attributes? 1, 2, 3. Well, it's good. Yeah, I expected more people, of course, but it's really so. For the others, you will see that it's a great technique. Really cool, really cool. First, what are my motivations? Why did it started? I attended the Linux forensic training a few months ago with Taz, and Taz is mentioning this technique in the training, and I had a crazy idea. Oh my God, what if we could try to abuse this technique, this system, to do some nasty stuff? Once again, I'm a good guy. So the idea was to better understand the system and see how we can try to, at the end, detect more stuff. That's what you will see. So my motivation is, first, Linux is important. It's crazy, for example, amongst my customers, how many people they think that Linux is safe. I'm running Linux because there is no malware running on my Linux. Oh, are you sure? Absolutely not. So let's have a look at this operating system. A lot of malware, also today, they try to be fileless. What does it mean? They try not file, a totally fileless malware. So a malware that doesn't touch the disk is impossible, because the first thing that the malware will try to do is to implement persistence. And to implement persistence, you need to write something on the disk, but not files. So we will see here how we will try to not touch the file system, so create real files, but write data somewhere else. Extended attributes, of course, it's a feature that is present to increase the capabilities of the OS, and by default, they are not used for malicious stuff. But it's always like this. Attackers, they just use techniques, tools, processes provided by the operating system to do nasty stuff. They try to abuse the system. Exactly the same here. What we have, for example, stealthy storage channel, we have persistence, we can try to hide a lot of stuff. The goal is to make your jobs more difficult, of course, to reduce the speed of analysis. What about a standard metadata in a file? If you are running on a Linux system, you have the file /etc host. You can display some information about it. And another tool that you can use is stat. And based on this, we can learn a lot of information about a file. The protection bits, how many symlinks we have, who is the owner, the group, the size, all the timestamp when the file was created, modified for the last time, accessed for the last time, changed for the last time, and so on and so on. It's regular files, which is the inode, on which device the file is stored, blah, blah, blah. Plenty of stuff. Easy. Do we need more metadata? Of course we can get more metadata. Another interesting tool that you have on Linux is debugfs. Debugfs, first, it's not available for all the users, so you need to use sudo, you need to be root to do that. And you see, first, the syntax is a little bit more different, a little bit more strange, because you need to provide the device, you need to provide some strange parameters, but we have a lot of interesting stuff. You find the same data, but it displays extended attribute. And you see here, system POSIX SCL default, POSIX SCL access, and a bunch of hexadecimal data. What is this system? What is this extended metadata? Extended metadata, so in short, it's ATTRS. It's a feature. So it's present in modern operating system, especially tied to the file system. In many file systems, you see that you have X4, XFS, BTRFS, and so on. You know that in Windows, today you have NTFS. You can have other file systems, but mainly NTFS in 99.99% of the time. But on Linux, you can choose your file system. If you prefer to use XFS, BTRFS for a NAS and stuff like this, go ahead. So it's a feature present in the file system. The idea is to play with key value pairs. So you have a key, and you assign a value, like this. By default, this data, as you saw on my previous slide, they are not readable by the user. So all of you, if you use Linux, your tools, daily, probably you use extended file attributes. You may compare them, it's really a rough comparison, to the alternate data stream that we have on Windows systems. That's almost the same. So we can use them for the same reason. For example, you can tag a file if a file has been downloaded from the internet, has been downloaded from a suspicious location, and so on. Key features, just to recap, you have a key, a name value pair, and a name always belongs to what we call a namespace. There are different namespaces. The value, and that's the good point, may contain anything, even raw bytes. Yeah, so you start to have some IDs maybe. By design, as I said, they are used for totally legitimate purposes. SE Linux use it for labels. Desktop environments you can have downloaded from like ADF, the alternate data stream on Windows and so on. The limitations is first that they may contain only a few kilobytes of data. Not easy if you have a big payload to hide something like this, but keep this in mind. Of course, not all tools may preserve them. So for example, if you transfer some file from server 1 to server 2, some extended file attributes may be deleted. So for an attacker, it's important to know when they will be preserved or not. And of course, they are not displayed by default, so it's a piece of cake for the attacker. What about this namespace? You have these different ones: user, security, system, and trusted. Of course, different namespace, and some of them are usable by any user, Some of them, you need some file permissions, some permissions on file to be able to write them. Don't try, as a regular user, to modify, for example, trusted on system namespace. Does not work. We need tools, of course, to analyze and to have a look at them. I show you debugfs, and there are some tools that any user can have. Set f-attr and get f-attr to set, so you write the extended file attribute, or you read it. By default, on many distributions, they are not installed. If you use Ubuntu, for example, you need to install the package attr. By default, they are not installed. But once you get it, you can do something like this. You do set f-attr, you specify the namespace, you create a node, hello, DFIR Prague, on the file, and when you do demo, so get f-attr, you try to display the user node, and you can, guess what? Yeah, almost, it's not really easy to read, the slide is a little bit messed, but you can see user node, hello, DFIR Prague. Cool. If you are not a command line guy, there are also some tools that can help you to display them. Just an example, Recall is a tool that you can install to do a full text search on your system. You can instruct this tool to also index your extended file attributes. Yes. Oh, thank you. Live patching. Wonderful. We can also have system calls. If you are a developer, the Linux has different API calls, get x-attr, set x-attr. So if you write some tools, have a look at the man pages. You can absolutely manage these attributes using your own programs. So let's dive a little bit deeper. And do we have here a new attack surface? Definitively, because we can hide, of course, malicious data in this attribute, like payloads, configuration for a malware. But there are some constraints. As I said, limited number of bytes per attribute. You have also different size depending on the file system. Don't forget this. You need access to the file to be able to write the extended file attribute. It's normal. And as I said, most backup systems, for example, they don't preserve these attributes. A proof of concept? No, that's definitely what I did. What if you could, so the question that which popped up in my mind when I was attending the 477, what if we could store some malware in this location? And let's have a look at this. Of course, we need to obfuscate and to hide this. So what I did, the idea was to start with a payload. This payload will be split across multiple files, because we have a limited number of bytes. We will XOR it, and then, of course, encode it in base64 to be sure that we have something that will not be detected. My payload will be pretty simple, a simple Python one-liner that will open a reverse shell on my local host port 4444. Probably you know this wonderful port. If you see this, it's bad. And we will spawn a shell. To do this, I will use a picture, and I will replicate the picture multiple times, and every copy of the picture will contain a piece of my shellcode. Here we go. I will not pass this, so trust me, it works. The script is available for you if you want, but it's a simple bash script. What I do, I start with this wonderful one-liner. So you see, you import socket, subprocess, blah, 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 blah. In Python, you just create a process that you will bind to stdin, std, or stdr to this port, and you will get a reverse shell. This payload will be split in multiple chunks. Every chunk will be XOR encoded, base64 encoded, and then I have here the magic. You will set the attribute to different copy of the picture, and we have this. When you execute my script, you encode the payload, and this shellcode, this Python script, will be split in 7 chunks. You see the different size and encoded and XOR, like this. Now, once you have this, you have a bunch of pictures in your directory. What you have to do, let's write a malware that will do the other way around. So it will read the different pictures, extract the extended file attributes, and do the reverse, decode base64, XOR again, and so on. So I wrote a POC. Once again, it's available on my GitHub, well, in Sans ISC project. How does it work? Easy. That's the recap. You execute you encode first. That's the previous slide. You have the 7 chunks. We have different pictures. And then we execute the POC. You provide all the pictures' name one by one. Everything will be decoded. Then you pipe this to Python, and ta-da! If you have a listener, you just start the netcat in another session. You will have your shell executed. Wow, wonderful. So now let's try, because you are a good guy, let's try to detect and see how we can hunt for this type of information. What you have to do, of course, try to hunt for existing metadata, metadata in files, so extended attribute. Have a look at unusual user, trusted, and so on. If they contain something that looks binary or strange, maybe you will be in a strange position. How you can do this? Have a look at your file system. ODD is wonderful for this. Have a look at your backup restore logs, and also maybe your EDR, some monitoring agent, can be able to capture this information. Getf-attr is the first super interesting tool. So the tool is easy because you can just get attributes from files. The good news is if you have this, you can do -rd, so it will do a recursive scan of all your directories. And if you do this on your file system, it will get all the files, and you will see this kind of information. The problem is that if you do that on a super big file system, it will take time. You will be flooded by legit information because, as I said, these attributes are used by many totally legit tools, so it's not the best one. ODD is also super nice. I like this tool on Linux. You can enable it. I recommend to enable it on your servers, of course. But once again, by default, it will not record activity related to extended file attributes. What you can do, but you can create a new rule. For example, xatr.rules. That's what you do. You rerun your ODD, and when you have some activity related to ODD, you will get these super interesting events that you can process using your SIEM, your tools, and so on and so on. So ODD is super cool. Another tool, so this tool, I wrote it by myself, well, with a bit of ChatGPT, of course, as usual. The idea is to hunt automatically for extended attributes. So the tool is named wrong button, xatr hunt. You have a bunch of parameters, and basically, it will scan your file system. So you see here, so I scan the / my complete file system. I'm looking for minimum extended attribute of 20 bytes, and you will get a nice overview. So how many bytes, which file, the attribute, and it will also extract the MIME time, the magic, do a SHA-256, and if it can detect it, it will dump it on a file. So for example, I did a test here. We have some bunch of base64 data. It will automatically decode everything for you, and you will dump on your disk a lot, well, probably shellcodes, configuration, and stuff like this. Once again, you have here the URL, so it's available on my GitHub account. It worked for me. I'm not a good developer. Usually I said I'm writing shitty code, so it works for me, but have a look at it, expand it, send me your feedback if you want, but it works pretty well on my system. How can you mitigate and harden? Because also we have to protect our customers and so on. First, restrict write access to your files. Because to be able to modify the extended attribute, you need access to the file. So I remember always that I saw one day in a company, some developers, they had an issue with the web server because some files were not accessible. What they did, change mode -R777 on the complete file system. Ooh, don't try this at home. So restrict access to your files. Control the software. So basically implement SE Linux and stuff like this to restrict access to files and allow only specific processes to access specific files. And ensure that your backups and all files transfer will, you have to know what they do with this extended attribute. Keep them, delete them, and so on. From an incident response point of view, there is nothing brand new. Just isolate your host, collect artifacts from the file system, maybe try to use my tool, and have a look if you have interesting information in this. So, we have 2 minutes left for some questions. It was very quick, because usually I do a very long task, but here it was challenging for me to do it in 20 minutes. I don't know, is there any question? Otherwise, of course, I will be available all day long. I'm leaving tomorrow morning back to Belgium. So, thank you for your attention, and any question, let me know. Oh, yes?
Have you tried doing this on a Mac because the extended file attribute code by...
No, but the macOS has exactly the same, so probably it will work in the same way.
And also there has been macOS-based malware that has been seen to utilize the extended file attribute to remove gatekeeper or expert detection capabilities.
I would say probably. Same, my comment will be the same. A lot of people, they think that macOS is malware-free. Come on. No, but basically, I know that macOS has the same feature, but I did not directly have a look at them. But of course, it's the same, yes. I don't see any... Anyway, if you don't have... Yes? Ah, sorry.
Does your scripts have dependencies on the live operating system to need the
It's a good question. I would say no. It requires some Python libraries, but that's the default one that I installed on any system. So I don't use obscure libraries, and there is no big dependencies, no. Because basically, it scans the file system, extract the extended attributes, unbase64, do some MIME type hunting and so on, so nothing really dangerous and suspicious. Yes? Yes? Yes, another one?
Sorry, in your experience, did you find a lot of this kind of payload?
No. No. I hope so. I hope that one day, but no. That's the idea that I had in my mind while I was attending the training. But I said, if I had the ID, probably bad guys will also have the ID. So I would say, let's be prepared. Yeah. So the goal of this presentation today was really, so a lot, well, some people raised their hand, you were already aware of the extended file attribute. No, you know that you have a lot, potentially a lot of interesting data stored in these extended attributes. That was really the goal of my presentation today. You must be aware that there are other ways to store data for files. No more questions? Anyway, I'm still available, so feel free to come back to me if you need to discuss about this topic or something else, malware, blah, blah, and so on. Thank you very much again.